In example G, our equation is 5 raised to the x squared plus 8 power is equal to 125 raised to the 2x power. Okay, again, this is an exponential equation. X is in the power. So we want to attempt to get the same base on both sides. 5 is the base on the left side. 125 is the base on the right side. And like I've mentioned before, it is most of the time it's easier to convert the bigger number into the smaller number. So we're going to try to rewrite 125 as a power of 5. So I'm going to go ahead and just rewrite the original equation using a different color here. I'm going to color code 125. Remember, what is in red will stay the same. Okay, so the original equation on the right, we have 125 raised to the 2x power. And I'm going to try to rewrite 125 as a power of 5. Okay, so 5 times 5 is 25. Times 5 gives you 125. So 5 to the third power gives you 125. So 125 is the same thing as 5 to the third. Okay, what's in red, both of those guys represent 125. All right, so the right side, 125 is raised to the 2x power. Okay, the left side, nothing is changing because it already has base 5. All right, so now we see base 5 appearing on both sides, but you cannot equate the exponents yet. You need to simplify the exponents before you can do that. Okay, the left is going to stay the same because we didn't make any changes. On the right, you have a power raised to a power. And we've seen from the other examples, when you have a power raised to a power, you want to multiply the exponents. So this is going to be 5 raised to the 6x power. Now we've reached a point where on both sides I have the same base and the exponents are as simplified as they can get. So now it makes sense to equate the exponents. So I'm going to set x squared plus 8 equal to 6x. At this point, the x has come out of the exponent, and it should be an equation that you know how to solve. When I look at this equation, the highest power of x is 2. It's a quadratic equation. So I either solve this using factoring or the quadratic formula. Regardless of which method I choose, one side needs to be 0 before I start. So I'm going to move the 6x over. That is going to give me x squared minus 6x plus 8 equals 0. Okay, I am going to try to factor this one, but of course the quadratic formula would work as well. All right, so x squared breaks down into x times x. I need two numbers that multiply to be positive 8 and add up to negative 6. That looks like it's going to be negative 4 and negative 2. Okay, so if you check yourself, this is going to be x squared minus 2x minus 4x, which combine to give you the minus 6x. And then negative times negative is going to give you positive. 4 times 2 is 8. All right, so now that we've factored, we need to take each factor, set it equal to 0, and solve. So we're going to get x minus 4 is equal to 0. X minus 2 is equal to 0. So you end up with two solutions. X is 4 and x is 2. So those are your solutions to this particular problem. Okay. All right, so let me get some room over here. So we can go to part H. Okay. All right, in part H, our exponential equation is 9 raised to the 2x power times 27 raised to the x squared power equals 3 to the negative 1 power. Okay, so you've got base 9 involved, you've got base 27 involved, and you've got base 3 involved. We need all the bases to be the same. Okay, so we want to go with the smaller number. We're going to try to make all of these base 3. All right, so let me color code again. We've got 9. We're going to change that to a power of 3. 9 to the 2x times 27 raised to the x squared is equal to 3 to the negative 1. Okay, so we're going to go ahead and rewrite here. Okay, so 9 is going to go in parentheses once we rewrite it. That 9 is going to still be raised to the 2x power. And then we're still multiplying here. 27 is going to go in parentheses. Exponent will still be x squared. And then 3 is already base 3, so we'll leave it alone. Okay, so 9 is the same as 3 squared. So 3 times 3 is 9. 27 is the same as 3 cubed. Okay, so the green stuff is equivalent, the red stuff is equivalent. Okay, everything is now base 3, but you need to simplify the exponents, okay, before you can equate them. All right, right here, you've got a power raised to a power. So we're going to multiply the exponents. This is going to be 3 to the 4x times a power raised to a power. We're going to multiply the exponents. It's going to be 3x squared. And on this side, 3 to the negative 1. Okay. At this point, you still cannot equate the exponents because on the left, I need 1 power of 3. And I have 2 3's as bases. Okay, I need 1 power of 3 equal to 1 power of 3. So you're going to have to combine these guys into 1 power of 3. Okay, so you have a power of 3 times a power of 3. So going back to the laws of exponents, when you have a power of a base times a different power of the same base, you want to add the exponents. So that's what we're going to apply here. So this is going to be, let's add the exponents. This is going to be 3 raised to the 4x plus 3x squared is equal to 3 to the negative 1. Okay, now I've got exactly what I want. Okay, I have 1 power of 3 on each side. The exponents are simplified. Okay, so we can go ahead and equate the exponents. And this is what we want to solve to get our solution to the original problem. Okay, the x's have come out of the exponent. You are left with a quadratic equation, so you can either factor or use the quadratic formula. Okay, one side has to be 0, so I'm going to add the 1 over and put it in standard form. So I'm going to have 3x squared plus 4x plus 1 equal to 0. Okay, let's see, we need some more room here, so I'm going to go ahead and just carve out some more room for us here. Since I did the last one with factoring, I'll do this one with the quadratic formula. All right, so A is going to be 3, B is going to be 4, C is going to be 1. Okay, let's plug into negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so we're going to get negative 4 plus or minus the square root of B squared minus 4AC all over 2A. Simplify under the square root. So we're going to get negative 4 plus or minus the square root of, this is going to be 16 minus 12, that's going to be 4, over 6. So we're going to get rid of this little box. So we're going to get negative 4 plus or minus the square root of 4 is 2 divided by 6. Okay, so we end up with 2 solutions here. Negative 4 plus 2 divided by 6. That is negative 2 over 6, which is negative 1/3. That's one solution. Okay, the other is going to be by picking the negative in the middle. Okay, so we're going to get negative 4 minus 2 over 6. Okay, That is going to be -6/6, which is -1. Okay, so there are your two solutions for this problem. Okay, all right. So, all right, so now let's go and try to do example I. Okay, all right. Example I involves the number e. Do not let this be intimidating for you. Okay, e is just a number. Okay, it's just some long decimal expansion, so we just write it down as the letter e. Okay, this one's not bad at all because all you have is on the left side e to a power equal to e to a power. On both sides, you have the same base, and the exponents are already simplified. So all you have to do is set the exponents equal to each other. That's it. Okay, so the x's have come out of the power. Okay, this is a linear equation. All you have to do is isolate the x. So we're going to add x to both sides. We're going to get 4x is equal to 2. And then divide by 4. So your x value that works is 2/4, which is 1/2. Okay, that's it. That's all you had to do for that one. Okay, so not so bad. All right, we've got one more of these. All right, so this is going to be example J. Okay, and your equation is e to the x squared is equal to e to the 3x times 1 over e squared. Okay. There's three little pieces to this equation. You've got this part, and this part. Each part needs to have base e. Okay. We're good on this one and we're good on this one. So you can't really have a fraction here. I need to see e to a power, not 1 over e to a power. Okay, so we need to eliminate that fraction. All right, so I'm going to write down what I have. I have e to the x squared is equal to e to the 3x times, and then remember, you can move this up and get rid of the fraction, okay? This is e to the -2, okay? So remember, if I go out to the side over here where I have some room, e to the -2, that's the same thing as if you wanted to eliminate the negative exponent, you would do 1 over the something, change the sign, you get 1 over e squared. Okay, so 1 over e squared is the same thing as e to the -2. Okay, so this rule works both ways, whether you want to eliminate the negative exponent or you want to eliminate the fraction. Okay, so this is the same thing as this. Okay, you have base e on both sides. Okay, but I need 1 power of e equal to 1 power of e. On the right side, we have two e's. We need a single power of e. So if you have a power of e times a power of e, that is when you are going to add the exponents, okay? Because if you have a power of the base times a different power of the base, you want to add the exponents. So the right side is going to become e to the 3x plus a -2. So if you add the -2, you're really subtracting it. Okay. Left side stays the same. And now I have 1 power of e equal to another power of e. So I can go ahead and equate the exponents. That leaves me with a quadratic equation. So you can either factor or use the quadratic formula, but you first have to get everything on one side. So I'm going to, from both sides, I'm going to subtract 3x and add 2. So that's going to give me x squared minus 3x plus 2 is equal to 0. And then I'm going to factor this one. This one looks like it'll be okay to factor. Okay, so we need to break this down. Okay, x squared breaks down into x times x. And then I think this will break down into this. Let's check. We might have to do some guess and check here. So x squared minus 2x minus 1x, those combine to give you the -3x, and then -1 times -2 is +2. Okay. All right, so we factored it. So now we just need to take each factor, set it to 0 to solve. So we get x minus 1 equals 0, and then that tells us x equals 1, and then x minus 2 equals 0, so x equals 2, okay? These are the two x values that work. If you take these two x values and plug them into the original equation, you will get a true statement, okay? So that's how you solve this particular problem.